Good morning. This is a talk about astrophotography. Astro meaning stars, photography meaning photography. So I'm talking about photographing the night sky, and perhaps you can see from the subtitle there, without ridiculously expensive equipment. Because a lot of people will tell you, if you want to do photography, well, all you need is a camera, but if you want to do astrophotography, that gets ridiculously expensive. If you want to photograph stars and galaxies that are out there in the universe, nobody can do that unless you invest huge amounts of money. I hope to convince you this morning that that's not necessarily the case. If you want to spend vast amounts of money, you can. But I'm going to show you how you can do it essentially on the cheap. So I'm going to talk about how anybody that's interested in photography generally can get started photographing the night sky, what equipment you might want to think about buying if your pockets are deep enough, how you can do it on a somewhat cheaper budget by thinking about the camera that you already own, and I'll be using this, of course, as an excuse for showing a number of images that I've taken, and I'll be finishing by just a comment about how, if you're venturing around the world to very dark sky sites away from light pollution, how you can make the most of that. For those of you who might be interested on making notes of some of the things I'm saying, don't worry, I've got handouts here, and I'll make electronic versions of the handouts available as PDFs to Neil and others in due course to circulate. So let's have a think about what you can do simply if you've got a camera and a tripod and very little else. There's nothing to stop you pointing it at the sky and taking a long exposure image. The difference between taking pictures at night and taking pictures during the day is, generally speaking, you need much longer exposures. So rather than taking a snapshot in a fraction of a second, it might be that you need to leave the camera shutter open for many seconds or possibly minutes, such as here, where some years ago I took a picture of the night sky, and perhaps you can see that over the minutes of this exposure, one star appears not to have moved, and all the others have moved slightly because the Earth is rotating. When you take a picture of the night sky over many minutes, the stars appear to move. Of course, it's not the stars that are moving, it's the Earth that is rotating, but the stars appear to move, and hence they can cause streaks if you take an exposure for more than a minute or two. And there's no reason why you should limit yourself to only a minute or two. With modern digital cameras, you may not want to take a very long exposure, but what you can do is take a whole series of short exposures and then add them all together using software. Software is free to do this for you, or you can spend money on software to do it for you. And here I've taken exposures over a total of 6 hours, not one long 6-hour exposure, but a whole load, 360 exposures, each of which is 1 minute, and then I've added them all together to make this star trail, to give you this impression of how the stars move. This, as you can probably see, was taken from an observatory site. This is taken from Mount Teide on the island of Tenerife. One advantage of digital photography is you can play games afterwards. You can take all of your images and then you can add them together to make yourself a movie to show the stars are moving or apparently moving in the night sky. This, again, is something that free software will do for you. That's the beauty of digital photography. Rather than think about wasting rolls and rolls and rolls of 35mm film, you can just take lots and lots of images, and they can all be stored on your little SD card, and it costs essentially nothing to store hundreds, if not thousands, of images, and then software can add them all together when you're done. Some astrophotography is about being in the right place at the right time. And you can very rarely get an image like this, a total eclipse of the sun, unless you happen to be standing at just the right place at just the right time. Total eclipses of the sun don't come around very often. The last one that was on UK soil was back in 1999. Some of you might remember that if you went down to Cornwall to try and see it. But here I went with friends to a site which I thought was probably going to be clear. It was the middle of the Sahara Desert, not known for its clouds. So I figured that that was very likely to have a nice clear view after being disappointed by the clouds in Cornwall in 1999. So yes, that's great if you happen to be in the right place at the right time. The same could be said of aurora. If you go to the Arctic Circle or the Antarctic Circle, then you can be treated to the magnificent lights in the sky, which we call the Northern Lights or the Southern Lights or the Aurora Borealis or the Aurora Australis. And here, again, I went with friends to Iceland and was treated to a magnificent display of these shimmering curtains of light that come down from the sky whenever the sun is quite active and producing a lot of particles that interact with the Earth's atmosphere. You get this glorious light in the sky. And this lasted for hours. On this particular night, the entire sky was lit up greens and reds. The sun has been quite active recently, and perhaps some of you have heard that aurora can be visible from much more southerly latitudes, like the latitude of UK. You don't have to go to the Arctic Circle, so you can see some of the colours in the night sky of the Northern Lights, here taken from my bedroom window. Generally speaking, not as spectacular as the aurora that you can see from the Arctic Circle, but it's still nice to see lights in the sky from the same effect of the sun producing particles which interact with the Earth's atmosphere and cause the atmosphere to glow. So let me tell you a little bit about how you can do astrophotography if you have very deep pockets. So what sort of telescope would you need in order to do some serious astrophotography? If you want to take pictures of stars being born, or if you want to take pictures of stars dying, or if you want to take pictures of galaxies that are way, way, way out there, what sort of telescope do you need? Well, you can, if you wish, invest in something like this. This is the Hubble Space Telescope. It's 35 years old now, so it's getting old. Hence, sooner or later, they are going to have to retire it. And in a couple of years, it will be retired, and maybe it'll appear on eBay. So if you've got enough money to spare, you can think about investing in a telescope that will produce fantastic images of distant galaxies and nebulae, like the famous Pillars of Creation. This is a star birth site. Stars are being born in these pillars, and this was one of the famous images that Hubble produced back in the 1990s and has revisited in decades since. It's amazing to think that the Hubble Space Telescope was launched in 1990, 35 years old and still going strong. It is pretty amazing. That would probably still cost $1 billion, even second-hand. If your pockets aren't quite that deep, you can come down a little bit. If you've got some 100 million or so to spare, you can buy this. It's a 747 with a telescope in the back. So this was a genuine research instrument. You can tell from the NASA logo on the very oversized tail here. So a telescope in the back there, the idea being this was an infrared telescope. It doesn't work so well at ground level because a lot of the atmosphere absorbs infrared light, so you fly it as high as possible. If you're at 10,000 meters or higher, you're above most of the atmosphere, not all of it, of course, and so you can get above most of the absorbing effects of the atmosphere. So for quite a few years, they flew a telescope in the back of a 747. Now we have a space telescope called the James Webb Space Telescope that does a lot of infrared astronomy, so this is no longer needed. So again, as of a few months ago, this 747 was retired. So again, watch eBay just in case this shows up. I don't think you'll get the telescope as well, but maybe it's worth having the 747 just for a bit of fun. For amateurs, we have to come down a little bit because most of us haven't got a few billion or a few $1 million or pounds to spare. But amateurs could, if they wish, buy telescopes, and these days the technology is such that you can get some quite nice telescopes costing almost anything from a few £100 to a few £1,000, and the sky's the limit if you'll excuse the pun. So you could go to tens of thousands of pounds. The choice is somewhat bewildering in terms of how many different telescopes are available to amateur astronomers, regardless of whether you just want a telescope to look at the night sky or whether you want a telescope to do astrophotography and take pictures of stars and nebulae and galaxies. So a lot of people like this style of telescope. It's reasonably compact. It's not the cheapest by any means. But even having invested a large amount of money in a telescope, some people still insist on the idea of turning it into tech spaghetti by adding as many cables and widgets and accessories as possible. It looks like a competition. He who has the most cables wins by the looks of it. And that's what puts a lot of people off. The idea that you have to invest a lot in the telescope and a lot in the camera and the technology and the computer, and how do you get the images off the camera and onto your laptop or your computer. It seems like a very tech-heavy hobby. And indeed, it can be if you want to go down this particular route. Some people who are expert in astrophotography will say, well, the real problem is the fact that the Earth rotates. There's not an awful lot we can do about that. Because the Earth is rotating, the target that you might be interested in is moving across the sky. And hence, if you want to get a nice image, preferably a nice long exposure image, you have to be able to point your telescope or your camera at the particular object and track it very accurately as it moves across the sky. So many astrophotographers will say what's really important is not so much the quality of the telescope, which sounds rather surprising. What really matters is the accuracy of the mount on which you put everything that will allow you to accurately track the sky. And some amateurs will say that you ought to invest more money in the precision of the mount that you buy rather than the precision or the specification of the telescope or the camera that you put on top of this mount, because tracking the sky is absolutely crucial. Well, indeed, it is important that you track the sky as accurately as possible. But when it comes to amateurs, you could ask yourself, well, that's a very nice mount there. Is it worth $10,000 for a mount that accurately tracks the sky? This is what we mean by ridiculously expensive equipment. Some amateurs think that's a good investment. A lot of amateurs will say, no way. I'm not going to spend almost more money on my hobby than I've spent on my house in the past. And so a lot of people will turn away from this idea. By the way, if any of you have the slightest inkling that you might be interested in astronomy and want to buy a telescope, don't do so before you've had a look at my talk on buying your first telescope. Some useful advice as to what to watch out for and how not to fall into any pitfalls and giving some charlatan your money without getting a good telescope in return. But if you do decide to buy a telescope, where are you going to put it? Most people would like to put it in their back gardens because that's nice and convenient. Back in 1982, I visited Palomar Mountain in California, a beautiful site that at the time housed the largest telescope in the world. This is the Hale telescope, the 200-inch or 5-meter diameter mirror in the Hale telescope. That was the biggest telescope in the world when I was born, and it was the biggest telescope in the world for most of my adult life. It's now been overtaken after many, many decades of service. So I visited it back in 1982. There's me with slightly longer hair. I think I might actually be wearing the same shirt. Yes, probably. So that was back in 1982. I visited this huge observatory dome and the telescope inside, and I said to myself, when I grow up, when I buy a house, I'm going to have a back garden big enough to have an observatory like that in the back garden. Okay, I had to downsize my aspirations slightly, and I ended up with... It's not a shed. I know it looks like it. It's not a shed. It was a shed when I bought it from B&Q, and then I converted it into a little observatory. You can tell that photograph is quite old, back in the 1990s. You can tell it's old because A, the shed is clean. Sorry, the observatory is clean. Very few spiders. And also the laptop in the background looks like a brick rather than the very slimline laptops that you get these days. But for a while, I had a telescope in my back garden, and that allowed me to get beautiful views of the moon and the planets and various other objects. And even something as local as just looking at the moon can be fascinating. Viewing how the shadows change as the sun slowly rises over various features, over the mountains, over the craters. And if you're lucky enough to have a large telescope and a camera, then you can obtain some superb images of the moon. And that probably doesn't do it justice, so let me zoom in a little bit so you can see a little more detail. The amount of detail that you can capture in a telescope image of the moon can be quite stunning. That's the top half of the image, and that's the bottom half of the image. That very prominent crater in the middle there is called Copernicus. It's in the center, roughly in the center of the disk of the moon, and is very prominent over many nights of the moon's phases. So it can be wonderful to look at the moon and to image the moon. You get this impression that you're floating over the surface when you see the amount of detail that you can see in a large telescope. Now, when it comes to astrophotography with a telescope, yes, you can produce some wonderful images. It gets expensive, but it can be very rewarding. I spent a little bit of time last summer using my camera, my Nikon camera, on a large telescope. There's my picture of the Pillars of Creation, not quite as good as Hubble's image, but a damn sight cheaper. Hubble cost more like $10 billion. This was still expensive, but not quite up to that scale. And I've also photographed stars that have come to the end of their life. This is a star that's basically died. And there's a rather colourful pair of nebulae there, pink and blue. One thing to bear in mind is that these colours are real. I haven't taken any of these images and artificially coloured them. You sometimes see that in professional images, especially those taken by the Hubble Space Telescope, the James Webb Space Telescope, etc. They are not natural colours. They have coloured the images so as to bring out as much detail as possible, or allow the scientists to get as much information as possible. All the images I prefer to take, I prefer to leave them in natural colour. So your eyes are not very good at seeing colour at night because there's simply not enough light around. But these would be the colours you would see if there was enough light to see what was going on. So not a particularly cheap way of obtaining images like this, because this was quite a large telescope. And one thing I should say, that it is possible to do astrophotography of our nearest star, the Sun, but of course, perhaps I don't need to say so, but I'll say it anyway. Never try and do this for yourself. Never try and observe the Sun. Never use binoculars on the Sun. Never use a telescope on the Sun unless you absolutely know what you are doing. It is not worth your eyesight damage, which is potentially a possibility. Here, I've used a particular telescope, again, not a cheap one. I got together with some friends and we put in a few £100 each and bought ourselves a telescope which is worth more than £1,000 in order to produce images like this of our nearest star. So we can see detail on the surface of the Sun, and we can see these huge prominences that come off the side of the Sun. It's these prominences, the plasma that's coming out of the Sun, that occasionally produces particles that come our way and give us the northern and southern lights, the aurora. They are, as it were, seen here as the edge effects that we can see on the edge of the Sun. But again, there's no easy, cheap way of getting an image like that. You have to invest a fairly large amount of money, a four-figure sum, basically. So having told you that you can invest billions or millions or thousands of pounds, let's get to the heart of the argument. How can you do it on the cheap? Let's just remind ourselves about cameras, and then I'll tell you about what I mean by a tracker. Again, apologies if you all know this, but basically a camera is just a device which focuses light, usually using a lens, onto either, in the old days, a piece of film, or these days, a CCD, a charge-coupled device, a sensor in the back of your digital camera. Generally speaking, these are monochromatic. In other words, they are black and white. They are not sensitive to color. If you want to take a color image using black and white film, you would take a black and white image using a red filter, and then using a green filter, and then using a blue filter to get three images, red, green, and blue, and then they can be combined together to give you a color image. These days, with digital cameras, you can still do that if you wish, and some astronomers, some astrophotographers prefer to do that because you get really good quality. But a lot of people say, I'm not going to bother with that. I'm going to take a charge-coupled device, a CCD, a sensor, in which the filters have already been placed on top of each pixel of the CCD sensor. And that gives me a color image. So, great, that means you can take a color image in one go. You don't have to worry about filters. But still, some astrophotographers will say, yeah, but you could, if you wish, use a black and white camera and then use filters. And you can see that the choice of astrophotography cameras, here I've just picked a few at random, but there are literally hundreds of different cameras that you could think about buying. There are thousands of telescopes that are available to amateurs. There are hundreds of different cameras made by lots of different camera manufacturers, ranging from perhaps a few hundred through to many thousand, and if your pockets are deep enough, you can pay tens of thousands of pounds for cameras. Some of them are color cameras, some of them are mono, they're just black and white cameras, and then you choose to put color filters in to give you color images if you want to generate color images. But when I started getting interested in astrophotography some years ago, I thought, well, this is great to be able to take images through a telescope, but isn't there a better way of doing that? I've already got a camera. I've got a camera that I use for taking pictures of, for instance, wildlife. I quite like wildlife photography. Occasionally, I go with friends on safari to Africa, and I like taking pictures of the wild animals. So I've already got a digital SLR camera. And it's quite possible that even if you're not in a photography group, everybody probably already owns a digital camera. I'm not necessarily talking about the tiny little things that are built into your phones, but a lot of people will have a compact camera or a bridge camera or a digital single lens reflex camera or a mirrorless camera. Lots of people are interested in one way or another in photography. And given that I've already spent hundreds of pounds on a camera, why should I spend even more on an astronomical camera? Why can't I use the camera I've already got? How good is a camera that's designed to take pictures in daylight? Let's face it, most cameras are designed to take pictures of your dog or the wedding or the sky or a field or friends. They're designed to take pictures usually in daylight. So if you were to use one of these cameras at night, which is sort of out of its comfort zone, how effective are they? So I thought, let's give it a try. I built myself a tracker. In other words, there's no point in trying to take a picture of a distant galaxy over half an hour and then have it blur as it moves because of the Earth's rotation. So I built myself a tracker. A tracker is simply a mechanical device, usually motorized, that will move the camera at the same speed as the Earth. In other words, it'll rotate the camera at the rate of 1 revolution a day. Strictly speaking, it's 1 revolution every 23 hours and 56 minutes, because that's how long it actually takes the Earth to rotate once on its axis relative to the stars. So it's just a question of buying a little motor and some AA batteries and a few resistors and a couple of hinges to build yourself what's called a barn door tracker that simply allows you to rotate the camera as long as it's lined up with the Earth's axis, and that's a question of finding which way is north and where's the North Star. Then it's a question of, right, that will then track the sky. I built myself one for a few tens of pounds, depends what you have lying around in your garage. If anybody would like to do the same thing and have a crack at that, here's instructions as to how you build yourself a star tracker for a few pounds. If you don't like the idea of a DIY project, you can go and buy star trackers. Star trackers will cost anything from £100 or £200. You don't have to invest thousands. So what's inside a star tracker? Well, not much. A star tracker is basically just something that's designed to rotate the camera at 1 revolution in 23 hours, 56 minutes. You pay to some extent for that precision. So there's a large wheel driven by a worm and a gearbox and then a bit of electronics and a few batteries. Generally speaking, they'll run for quite a few hours. The one I've got at the moment runs for about 24 hours. You can use it night after night after night without thinking of replacing the batteries. That's how you use it. It's a little white box. You usually stick it on a tripod, and then put your camera onto that. This disc here rotates at the relevant speed to track the sky. All you need to do is to make sure it's lined up. That's why you have this little telescope on the side there, a little finder scope, if you like. You simply point that at the North Star and make sure that it's lined up with the Earth's axis. So as the Earth turns, the camera turns in the opposite sense and keeps all the sky nice and sharp, all the stars nice and sharp. So that's Nikon camera with a telephoto lens on a sky tracker. And I assure you that this is the same camera and lens that I use to take wildlife images. This picture of a lion taken on safari a couple of years ago was taken with my Nikon DSLR camera and a 300mm lens. 300mm lens is the longest lens that I really want to use because anything bigger would just be too heavy. And I wanted something that was nice and compact so I could take it to Africa and I wouldn't be weighed down with anything that was too large or too heavy. So the same camera and the same lens that I use for taking pictures of lions, exactly the same setup to take pictures of the night sky. If I ever go to Africa, I use the camera and lens to take pictures of lions during the day and the same setup at night to take pictures of the night sky. So let me show you some of the images that I have taken with my daylight camera, in other words, my totally unmodified, what's the word I'm searching for here? It hasn't been modified in any way. It hasn't been adapted in any way for astrophotography. It's just the same daylight camera and lens. And I've used that on a star tracker and obtained quite a few different images. This is taken with different lenses. Some of them are wide-angle lenses, some of them are telephoto lenses. One thing you notice immediately is the universe is colorful. This is natural color. I've tried to make sure the colors are as clear as possible, but I have not artificially colored any of these images. The universe is a colorful place. So these reds and pinks and blues and yellows are genuine colors of these objects. So I'm not dissing in any way the idea of buying an expensive telescope. Some people, some amateurs, have used telescopes and cameras on telescopes to produce absolutely superb images. That is true. I would argue that if you want to do astrophotography with a telescope, that can be enormously rewarding, but it will take time, it will take effort, and absolutely it will take cash if you want to do it properly. My argument is use the camera you've already got and use a star tracker. Just to let you know that you don't have to go to the darkest places in the world. You don't have to go to darkest Africa to see the night sky. Even if you live somewhere at random, like Liverpool, in which you have some light pollution because of street lights, when you take an image of the night sky, there will always be some glow from whichever street lights are closest to you. But software, either free software or purchased software, can do a very good job of teasing out what's in there and showing you these distant objects, stars, nebulae, galaxies, against the backdrop of the night sky. So that is simply software that takes these images coming out of the camera and turns them into something that look rather nicer. It helps if you can go to a dark sky site, because then your software has less work to do. It doesn't have to try and tease out the nebula from the background, because the background glow hopefully will be almost zero if you can get away from streetlights. Go somewhere nice and dark, middle of Wales or Scotland or one of the national parks, etc. But you don't have to. If you are in light polluted areas, don't think that you can't do any photography of the night sky just because you have too many streetlights. Modern software is very good at mitigating that. So let's have a look at a few images. Here's an image of a nebula. This is a nebula called the Rosette Nebula. Perhaps you can see why it's called the Rosette. It's got a characteristic pink color because it's full of hydrogen. Hydrogen glows pink. When it gets excited, hydrogen glows pinky red, and that's why a lot of my images tend to be pink or red. So this is a birthplace of stars. Stars are actually being born here. Some of those stars right in the middle of this nebula are very young. They've only been born perhaps in the last few million years. That might not sound much, but remember, stars can live for many billions of years, like our sun. So stars that are that young are effectively just babies. So we can look out into the universe and we can see star nurseries. We can also see the opposite of that. This is a star that's about to die. This is a star, you can hardly see the star itself. It's right in the middle of this nebula. And for thousands of years, this star has been so unstable that the outer atmosphere of this star, the outer layers of this star, have been shrugged off into the interstellar medium. And so what you can see here is this rather odd-looking flower shaped here, the pink. That is what used to be the outer part of the star that's been shrugged off for thousands of years. And so this star is being watched very carefully because we think this is getting very unstable and is showing signs of coming to the end of its life. It's a very massive star. Unlike our sun, when this star dies, it will die as a supernova and there will be an enormously bright flash. And then we will see the light from the supernova itself, blindingly bright compared to the nebula, and it will take weeks, months, even years for it to fade away so that we can again see the nebula that is left behind. When a star does go supernova, it sometimes blows itself apart completely. This is a star that went supernova about 15,000 years ago. We're not absolutely sure because we haven't got it on record anywhere. There's no written records of this star actually going supernova, but looking at the size of it, we think this star went supernova about 15,000 years ago. It's almost impossible to tell whether any of these tiny dots in the middle are what's left of this star, but this bubble that you can see, the edges of this bubble, are the material that was thrown out when this star blew itself to pieces 15,000 years ago. This was taken with a 300mm lens, the same lens that I used to take pictures of lions. In this particular case, this is one instant where this isn't taken from the middle of Africa. This is taken from my front garden, which is very close to a street light. So I've actually used a filter to reject any of the light coming from the street lights. So in other words, I've tried to reveal this nebula by suppressing the amount of light produced by light pollution in my front garden. The nearest street light was about 10 meters away from the camera when I took this image. So it is possible, either with a combination of software or using some filters, to actually bring out detail like this supernova remnant. Here's a star birth region. It's one of the closest star birth regions to our own solar system. This is only about 400 light years away, which is quite close on a cosmic scale. It is close in the sense of our Milky Way galaxy being 100,000 light years across. This is only a few hundred light years away. So again, stars are being born in this region. I took this photo quite a few years ago using a 135mm lens, a rather modest telephoto lens for those who know their focal lengths in photography. So I wanted to catch all of this region, but more recently I asked myself, well, I wonder what would happen if I used a different lens. What if I used a 300mm lens rather than the 135mm, and what if I sort of look in this area to get a little more detail? So I tried taking a long exposure of that region with a 300mm lens. And what you end up with is something that looks virtually like abstract art. It is a very colorful region. There are parts of the nebula that are glowing yellow or orange. There are parts of the nebula that are scattering light in the blue part of the spectrum. There's a very bright triple star there. There's various other stars. And maybe you can see that there are some dark regions as well. This is dusty regions, tiny particles of dust, barely micron in size, tiny fractions of millimeter. There is a lot of dust out there between the stars. In effect, that's what we are made of. Our solar system has ended up making a star and planets because of all the dust that's floating around. And here we can see that dust obscuring some of the light from more distant regions. So we see these beautiful colors. We see the blues, we see the yellows, and we see this dark region in this wonderful tapestry of this star-forming region, which again is one of the closest to us, and hence we can get a lot of detail there. But we're not limited to staying within our galaxy. With the same setup, again, the 300mm lens, my lens of choice, this is one of our neighboring galaxies. It's called the Andromeda Galaxy. It's a very similar galaxy to our own. If we were able to step out of our galaxy and look back at it, that's pretty much what it would look like. We think Andromeda is almost a twin of the Milky Way. It's a large disk, some 100 or so, 100,000 light years in diameter. In other words, light would take 100,000 years to go from one edge to the other edge. We can see that it's a spiral sort of structure. You can see these dark dust lanes. We're seeing it close to edge on. It has a couple of little smudges here. Those are satellite galaxies, small galaxies that are orbiting around the Andromeda Galaxy. So this is one of our immediate neighbors, meaning it's only 2.5 million light years away. In other words, we're seeing it as it was a couple of million years ago. Light travels at a finite speed. And so in this case, light left the Andromeda Galaxy 2 million years ago, 2.5 million years ago, and has been traveling towards us ever since. You open the camera shutter and you capture that light. How far can you go in terms of if you've got a camera and you want to photograph distant objects in the universe? The universe is huge. How far can you actually image? 2.5 million light years. Is that the limit? By no means. We can look a little bit further and we see a whole collection of galaxies. This is looking in a particular region of sky where we know there happens to be a lot of galaxies. Every smudge you can see here, some of the smaller dots are probably stars, but all of the larger smudges, and there are about 50 of them in this image, all of the large smudges are galaxies in their own right, possibly similar sort of size to our Milky Way. This collection of galaxies is about 50 million light years away. So again, light from these galaxies left the galaxies 50 million years ago. Not quite at the point where T-Rex was stomping his way around the Earth, but we're talking about a long time into the past. Is that even close to the limit of what we can get with a camera that's designed to take pictures in daylight? How far back into the universe, how far back in time can we actually look with a camera that's designed to work in daylight? During COVID, I set myself that challenge because I couldn't go to the pub and talk to my mates. I said, okay, what can I do stuck at home? Let's just see what is the most distant object I can catch with my Nikon camera sitting on my tracker. So I gave that a go. I got the tracker out and I pointed it at a patch of sky where I had already looked up there should be a very distant galaxy. I'd looked up what it was and where it was and how distant it was. And it's not that dot in the middle, that just happens to be a star close to this very distant galaxy. This very distant galaxy is called a quasar. A quasar is simply the name we give for a galaxy which has a very bright nucleus, bright enough to be seen from enormous distances. So I knew the location of where it was in the sky, so I put my camera and telephoto lens onto the tracker, aligned it to the North Pole, and then took the longest exposure I could get away with. This is 2020, in the middle of summer, during the lockdown. There isn't much dark sky, as you know. At this time of year, it doesn't get dark until quite late in the evening, and then dawn occurs very early, so there's only a couple of hours of nighttime. And so I took as many exposures as I could during the night, and I expected the middle of that square to show this quasar at enormous distances. And when we blow that up, and we have a look at that, that is the least spectacular object in this particular presentation. That dot there that you can see indicated by the two red lines is that distant galaxy. I know that because I've checked its position very, very carefully. So most of the light from this distant galaxy has appeared in just that one pixel. Let me blow it up. It is almost just 1 pixel in the image. The sensor on this particular camera has 20 million pixels in it. It's a 20 megapixel image. But most of the light from the quasar has only gone into one of those pixels. I brightened it a little bit so you can see some light has gone into the neighboring pixels. But what is absolutely incredible is the distance to this object. It's not the most spectacular, and aesthetically speaking, it's not the most pretty of images. But it is absolutely astounding that it's possible to image this object because it's at the incredible distance of 25 billion light years. Light has been traveling for most of the history of the universe in order to reach my camera. The light left this galaxy more than 12 billion years ago, long before the sun existed. Long before the Earth existed. We're not talking dinosaurs. There was no sun and no Earth when the light left this galaxy. For 8 billion years, the light was on its way. For the last 4 billion years or so, the sun was born, the Earth was born, life appeared on Earth, and then eventually the shutter opened and the light went into the camera and produced that image. The fact that light has been traveling for 90% of the age of the universe in order to produce that image, and yet it still produces something that you can identify as, yep, that's definitely it. Not the most spectacular image ever taken, but the fact that it's possible to catch light from the other side of the observable universe using a camera that you otherwise take pictures of lions with, I think is absolutely amazing. It's a testament to the technology available to all of us not necessarily the technology in your mobile phone, but certainly the technology in your compact camera or bridge camera or SLR camera, the technology available to you should not be wasted just taking pictures of your dog or your spouse or your kids or your grandkids. That's a waste. No, go out and take pictures of the entire universe because your cameras are capable of doing that. Let me just finish with a few comments about taking pictures from my favorite place, if I can ever afford it, is on safari. I'm interested in wildlife, looking at wildlife with binoculars or with my eyes. I'm interested in photography, and therefore there's an overlap between wildlife and photography because if I see a lion, I obviously like the idea of being able to photograph it. I'm also interested in astronomy, so again, those same binoculars allow me to look at the night sky as well as looking at lions in the distance during the day. And if I'm interested in photography, well, there's no reason why astrophotography shouldn't be one of my interests. The top two overlap simply because if you go somewhere, for instance, the middle of Africa, in order to look at the wildlife, you've probably also gone somewhere away from streetlights. And if you're away from streetlights, that means you have astronomy. You have beautifully dark skies. So the idea of going on safari, some friends and I hit on this quite a few years ago. If you go on safari, well, that means you can see and take pictures of animals by day, and you can see and take pictures of the stars by night. Sleep when you get home. It's pointless wasting your holiday by not taking as much as you can during the day and during the night. So the idea of taking a little tracker like that, it's fairly small, it's only about the size of my hand, it's an easy thing just to slip into your luggage. And so if you're taking a camera anyway, because you're interested in taking pictures of whatever is out there during the day, if you take a tracker with you as well and you get away from light pollution, that means you can get some wonderful images during the night. The idea of a tracker normally is you use this little finder scope just to make sure you're pointing at the North Pole, to make sure that your camera is rotating on the same axis that the Earth is rotating on, so that the camera effectively, if you like, derotates the Earth. As the Earth moves and the sky appears to move, the camera will then track. So you need to make sure that it's lined up nicely on the North Pole. That you can do very easily because there are apps available saying when you look through this telescope, the North Star, the little Polaris there, ought to be at that particular location. You don't have to worry about why. You can simply use the app and say, well, the app knows where it is in the world because it uses GPS. The app knows what the time is, so it knows that at this time on this day, if you make sure the dot is in that position, then you're lined up bang on the Earth's axis and your tracker will track the sky very nicely. Well, that's easy from the UK, but it's not so easy from Africa. The Earth's axis points to what is called the North Celestial Pole. Polaris, the North Star, is just next to that. It's slightly off, but we can think of that as pointing towards Polaris. So if we're here in England, that means the North Star is sitting up there in the sky in the northern direction, about 50-odd degrees up in the sky, an easy thing to find. But if you go to Kenya, you're sitting on the equator. If you're on the equator, where's the North Pole? Well, the North Pole is on your horizon, and the South Pole is on your other horizon. So how do you line up your tracker on the pole when it's hidden behind elephants or distant hills or something? It's a bit tricky. So lining up on a pole is easy anywhere in the world except on the equator. And unfortunately, Kenya, one of my favorite places to go, is on the equator, give or take a degree or two. So you have to be a little more creative and say, well, I can't see where the North Pole is, but I know which way is north, because either I can look at the stars or I can get a compass out and I can say that way is north, and I know the North Pole is on the horizon, so I can point my tracker in that direction and then point my camera at whatever object I want to take a picture of. In Kenya, when you get away from streetlights, the Milky Way can be absolutely spectacular. If that's what the Milky Way looks like as seen from the UK, where you get a few smudges of light coming over when you get away from streetlights, then when you're in Africa, the Milky Way stands out and is almost bright enough to cast shadows. It is truly astounding if you get away from light pollution. And your eye will pick up all of this detail. Again, we're looking at lots of stars in the Milky Way. We're also looking at some dark patches. These are dust lanes, dust patches in the Milky Way, which are obscuring light from more distant parts of the Milky Way. And all of this can be picked up by eye. With a wide-angle camera, you can take pictures and then you start to see color, because your eyes are not good at seeing color at night. Your eyes are designed to work during the day and pick up, your color vision is picking up light during the day, but at night your eyes unfortunately do not work well with color. But any picture you take, a long exposure here, in this case quite a few minutes exposure taken with a wide-angle lens, you can perhaps see from the black rectangles in the corners, this is a mosaic because the Milky Way spreads over most of the sky, and so you can pick up a glorious vista of the Milky Way simply by taking a few wide-angle images. If we have a look at a little bit more closely, what's this interloper, this very bright object there? No, it's not a star. That is actually the planet Jupiter, which happened to be in the sky at the time I was trying to take this picture of the Milky Way. And over on the left-hand side there, that's actually Saturn. These move as they move around the sun, so from one year to the next, they will not appear into the same part of sky. So if I ever take that view of the Milky Way again, Jupiter and Saturn won't be there. I'm not going to bore you with all the details, but when you take a digital image, you can, if you wish, zoom in and see all sorts of details of, well, what else is in there? According to this atlas, there should be a cluster over here and a nebula over there. And the more you look, the more you realize there's a huge number of objects in this wide-angle view, which, if you wish, you can then zoom in and start to identify. Back in the 18th century, Charles Messier catalogued a lot of these objects. He was in France and he was cataloguing everything that he could see in the sky which looked interesting. He was actually interested in comets, and so he kept getting, no, that's a fuzzy object, but that's not a comet. I'll make a note of that so I don't record that again. There's an interesting object. Is that a comet? No, that's a star cluster. I'll make a note of that. And so he catalogued a whole load of nebulae and clusters simply because he didn't want to confuse them with comets. But we now have a catalogue, the so-called Messier catalogue, of all these interesting objects in the sky. You might say, well, isn't that a bit odd that they stop and that there's no interesting Messier objects down in the bottom right of the image? Well, no, that's not altogether surprising, because this was taken from the equator. And when you're in France, you can only see so far south. So in other words, Messier did all of his work from France, so he could only see objects a certain way down, and then the horizon stopped him seeing anything further. So there are all sorts of clusters and nebulae and objects either in the Milky Way or across all of the sky that can be picked up with wide-angle lenses, as well as interesting objects that you can go and find with a telephoto lens. The bottom line is, if you're going somewhere interesting where you're going to have dark skies and you're remotely interested in photography, why not think about a tracker? Build one yourself for a few tens of pounds, or buy one. It's a relatively small, compact thing. It adds very little to your luggage, and it gives you the option of taking images of the Milky Way or of distant nebulae or of distant galaxies when you go on your next holiday. The universe is absolutely vast and very colourful. And if you have a photography group in your U3A, maybe you can convince them, if they aren't already convinced, that the idea of doing astrophotography does not have to involve ridiculously expensive equipment and can be done on the cheap and still produce some wonderful images. Thank you all very much.
Thank you.